Hello and welcome to Extension 2 Mathematics, where as the title says, the real and imaginary collide. Before we formally introduce complex numbers, it makes sense to go back in time to where we first meet complex numbers historically, which is in Italy during the 1500s. Meaningful employment as a mathematician meant making a name for yourself, and this led to secrecy in results rather than the more modern approach of publishing results. Mathematicians would often challenge each other to a duel, a mathematical duel, not with guns, that set each other a series of problems, and the one that could solve the most got the street cred. The more street cred you had, the bigger name you got. The bigger name you got, the more likely you were to reach that meaningful employment that they were all looking for. Our story has three main characters, the first character being Niccolò Fontana Tartaglia. He's most famous for discovering the cubic equation. Now, as I've mentioned, Tartaglia, rather than publishing the result, kept the result secret. He much preferred to use it in these duels that we've been talking about. Somehow, though, our second character, Cardano, convinced Tartaglia to provide him with the result. Cardano was already an established mathematician who had that job security. Now, he was very much interested in the history of how this result came about and how to use it, how did it work. He was a mathematician. We love to know how things work, and that's pretty well what he was interested in. He wasn't interested in the fame or the fortune. He wanted to know how this thing worked. How did Tartaglia come up with the result? What made it tick? Now, in his research on the result, Cardano discovered that in fact a third main character was involved, Scipione del Ferro. Del Ferro had independently discovered the cubic formula as well, and it turns out he discovered it before Tartaglia. Now, this was interesting because I haven't mentioned it yet, but Tartaglia had promised the result to Cardano only on the agreement that he would never publish the results. Once Cardano discovered that Del Ferro had in fact independently discovered the result, and in fact before Tartaglia, he no longer felt the need to keep that. So publish he did, and he published in a monumental book, and that book we're about to introduce. The book is today known as Ars Magna and was a book on arithmetic. Amazingly, at the time, negative numbers were something that mathematicians were still grappling with, and Cardano wrote the book primarily to introduce the idea that the arithmetic that we knew for positive whole numbers worked for negative whole numbers as well. He built that up systematically over the course of the book. During his work, he also introduced the quadratic formula, it was already known, but examples using the quadratic formula, built up the cubic formula, and in fact one of his students also found the quartic formula as well for degree 4. And then on page 66, as you've just seen in the video here, something amazing happened, and that's the premise of our whole course now. He introduced a wonderful little result, a wonderful little problem to do with a square and breaking up a line segment into two pieces. And during that work, he in fact introduced complex numbers, the first ever recorded demonstration of complex numbers. Putting it in context, remember what I've just said, this whole book is about negative numbers. These were numbers that were doing their heads in at this time. And then he introduces something even more monumental to do with the square root of a negative number. So not only are we dealing with negatives now, we're dealing with square roots of negative numbers. And it's an amazing thing to see. And there it was, right in front of your eyes, the first introduction of complex numbers. Interestingly, there is a throwaway line in it where he demonstrates this result and then talks about how useless these things are. Can't get everything right, I guess.